Okay. I didn't coordinate with Björn, but I was glad to hear about the AI blind architecture because it really lines up nicely to our next talk. A couple of years ago, Air Canada deployed a chatbot onto its website. Then a grieving customer who just lost a family member asked a question about bereavement fare policy, essentially the ability to get a discount for the flight, refund for the flight to get to the funeral. The chatbot gave wrong information, politely, confidently, repeatedly. The customer booked based on that information. And then when they came to ask for the promised refund, Air Canada said, that wasn't us, that was the chatbot. The case reached court. Air Canada tried to disclaim responsibility. As you can see in the article, they said that the chatbot was responsible for its own actions. The chatbot is its own legal entity. Tribunal ruled them liable anyway. So what did we see? Air Canada's chatbot made a promise. Air Canada didn't know. The judge didn't care. Somewhere, an engineer had no idea what their AI was telling the customer. Okay? Their dashboards were green, their CEO was not. So all looks fine, everything's green across the board, but the system was actively harming the customer. This is the gap we need to close. AI is in production now. Our tools didn't get the memo. Who has an LLM-based app now running in production or heading there? With a show of hands. Okay, so I'm telling you by next year you'll see many more hands here. And the fact is that agents are everywhere. See it in customer support, code generation, data pipelines. Production agents are now on our hottest paths, and we've never had less visibility into a workload. I'm Dotan Horovits. I'm a senior open source advocate at AWS. I'm also a CNCF ambassador, so a pleasure being here again with the local cloud native community of Munich. I'm also an OpenSearch ambassador under the Linux Foundation, and I also run the Open Observability Talks podcast, already now concluding the 6th year. So you get the sense, observability is a passion area of mine. And this is why I'm here to talk to you about the future of observability. AI workloads broke our most fundamental assumptions about latency, about throughput, about payload sizes. Right? What was the mental model for microservice observability? Right? We talked about millions of requests per second. We talked about millisecond latency and relatively small payloads, right? Maybe up to a kilobyte on average. AI flipped these trade-offs. We're now talking about much, much lower latency, maybe hundreds to thousands requests per minute, not millions per second. Also, much higher latency tolerance, because if you think about it, the LLMs themselves take like seconds, maybe tens of seconds even round trip, so no point in optimizing on the millisecond now. And the payloads are, on the other hand, much larger now that we have the prompts and we have the completions, and maybe also in multimodal inputs, it can even reach megabytes. So, and this is the mindset that we had that our tools now need to adjust. Your P99 latency alert thresholds are meaningless now, okay? 8 seconds isn't the problem, it's a Tuesday. And it's not just flipping our trade-offs. AI also changed our very questions. What did we use to ask up till now, right, in observability? Basically, when you bring down to the basics, we asked, is it up? Is it fast? Did it error? All these questions are relatively simple questions. They're binary. They're status code friendly. With AI, we started asking entirely new questions. For example, did it hallucinate? Remember the story with Canada? So no status code tells you this, no existing alert fired, but as we saw, it's a major risk, as we saw in the case. So with AI, success is no longer binary. And many of the failures are actually semantic rather than technical. Enter the world of evaluation, evals. Okay? Now with AI, we need to monitor accuracy, relevance, hallucination rates, all of which, by the way, if you notice, live on a spectrum. They're not binary, right? Furthermore, we now need to constantly run evaluation to detect model drifts. Because the real world evolves and shifts away from the snapshot that is embedded into the training data of the model. What did it actually cost? Let me tell you, LLMs have long passed our IT infra costs. In some teams, by the way, it even surpassed the employee headcount costs. I saw this just last month. I don't know if you recognize, this is the founder of OpenClaw. He tweeted this, and I couldn't help noticing, the yellow is my marking on his tweet, that, I don't know if you can see it well, over 1.3 million US dollars a month for OpenAI usage. $1.3 million for 1 month. Just last month. And by the way, you think this is anecdotal? Think again. Microsoft has reportedly reduced access to Cloud Code for its employees after soaring costs, so they're now redirected to their own GitHub Copilot. Uber's CTO said back in April that the entire 2026 AI budget was blown away by April due to heavy usage. I think they reported the engineering average like 150 to 250 US dollars a month on tokens, with the heavy users reaching $500 or even $2,000 a month, just for the tokens for one engineer. NVIDIA, VP of Applied Deep Learning, said back in April that for his team, the cost of compute is far beyond the cost of his employees. Just examples, okay? Token economy is changing everything. And you need a way to monitor it. AI also brought a whole set of safety concerns we haven't encountered before, okay? Who knows this example? So that's a story of Google's Gemini's response when they were asked to generate portraits of the founding fathers of America. You may detect a slight bias here. Welcome to AI safety. There are various aspects of ethical LLM that have arisen in this new era. Bias detection is one of them. And by the way, it doesn't have to be that blunt. It could be subtle patterns where the model treats differently different groups. And also content safety, talking about things about toxic responses, harmful, inappropriate responses, and generations we need to intercept before they reach the end user. Hallucination rates, bias detection, ethical LLM these aren't theoretical concerns. These are operational, legal, reputational risks that are happening now. And none of these have a status code. So AI didn't only affect our production, it also transformed how we develop software. Vibe coding is the new norm. I heard now with the other lecturer, with Bjorn, that it's over 90%. I found this stats from Stack Overflow's recent survey. It's for 2025, so it only came out in April. But they talked about 84% of developers now use or plan to use AI tools. I wouldn't be surprised if it's over 90% by now. And what does it mean? We code faster, but are less familiar with our code. The developer is shifting from a writer role into a designer. Everyone is doing intent-driven development now, or spec-driven development, which is a fancy term to saying that we tell our AI agents what we want them to code for us. And that brings a whole set of additional questions. Like, why did he do that? Or things like that. Like open source, the source of truth is shifting from code to AI agents. So when we look at the AI agents now, instead of the code, what questions do we ask? Why did he do that, for example? Like, AI is non-deterministic by nature. So the same input can produce different outputs. And a tweak to a prompt or to a skill can easily produce, invoke different tools, different APIs. Prompts are brittle. So when you do small prompt changes, it can drastically change the outputs that you get and the behavior. So how can you validate the correctness of our output? How do we know if the agent did the right thing? And if my tweak actually made things better or worse? The traditional replay, reproduce techniques don't work here, right? And also for explainability, how can you explain and show how we got to that conclusion? And it's not just about correctness. The lack of determinism can also make the cost non-deterministic, right? Same input, different tool sequence. The token cost can easily double, if not more. And also in performance, the different choice of tools and invocations can dramatically influence the performance of your query. Our traditional IDE doesn't handle that. Our debugging and testing doesn't cover that. And we end up developing our AI agents and our agentic workflows blind. So how do I gain the needed observability? Okay? Where does observability live in my AI stack? And in fact, each and every one of these layers in your AI stack has important signals and failure modes that you need visibility into. Starting from the very basic infrastructure, again, the previous talk covered some of that. In addition to the classic compute, network, storage, suddenly you have a specialized infrastructure such as GPUs and TPUs and so on that you need to monitor. Then on the model, tokens, latency, quality, with the RAG, retrieval augmented generation, you need to understand the retrieval quality, the freshness, the relevance, orchestration guardrails and chains, and agentic, so the agent to agent and agent to tool. Each and every one of these is an important signal that can help you get observability. What about logs, metrics, traces, the good old signals? Are they still relevant? Yes, very much so, and in some cases even more so than ever, like in the example of tracing. So who uses tracing today in production? Not for AI, for general production. Okay. You need to have more hands by next conference, and hopefully this will help you. So traditional trace essentially shows you the timing and the service boundaries, right? But that trace treats your agent like a black box, okay? You may see something like post/plan, took 14 seconds, and you got 200 okay. Behind that span, you may have had like 14 LLM calls and 4 tool invocations and maybe 3 retry loops and maybe a hallucinated answer. Agents run multi-step reasoning that doesn't fit this model. We need to shift to AI traces. An AI trace gives you the full reasoning path. So not just agent called an API, but rather showing you the prompts, the completions, the tool calls, the sub-agents, the retry loops, the RAG retrievals, everything you need in order to understand the full logic that brought you this answer. Now, as you might have understood, I'm an open source advocate, and I know that many of you here at Cloud Native Summit are as well. So I'm happy to tell you that the open source community, is already building solutions to address this. I want to share a couple of projects that I've personally been involved with that you may find interesting in that regard. First is OpenTelemetry, or OTel, as we call it. Who uses OTel in production? Okay, very good. So OTel is a CNCF project under the Cloud Native Computing Foundation. And actually, it just reached graduation last month. So let's give a big round of applause. Come on, Cloud Native Summit. For everyone who was involved, the maintainers, the contributors, everyone who contributed to that great milestone. I covered that on my podcast last month, along with profiles, OTel profiles reaching public alpha and some other updates. So if you want to deep dive into that, you can scan the QR code and get the full episode with one of the maintainers. So OpenTelemetry is already the de facto standard for logs, metrics, traces, also now profiles, as I mentioned, where it helped standardize and avoid fragmentation across tools, across vendors. Now, we're having the same problem with LLM providers, with agent frameworks, with tools, etc. So without a standard set of attributes for model, token, prompts, tool calls, no observability tool can query across your agents and agent workflows, okay? The Gen AI SIG, Special Interest Group, is the community response to this exact problem, okay? We want semantic conventions for AI telemetry. This means that you have a canonical vocabulary to describe your agent interaction across prompts, tool calls, LLM calls, and so on. Like the examples you see here, like request.model, input tokens, output tokens, and so on. By the way, I covered the Gen AI SIG with one of the SIG leads and all the standardization effort in my podcast as well, Open Observability Talk. So if you want a deep dive with one of the SIG leads, you can scan the QR code and get more information about that. So once we have these attributes, this metadata in place, now we can start asking questions to gain observability. For example, here I use the PPL, Piped Processing Language, it's part of OpenSearch, to query the token spend by model and agent in the last hour. And you see the highlighted attributes from the semantic conventions. And of course, similarly, you can query for a tool failure rate by agent, sub-agent P99, and anything else that you probably do already in your production environments in the traditional observability. Another interesting project I've been involved with is OpenSearch, a top-level project under the Linux Foundation. Who uses OpenSearch, just to get to know? Okay, we have a few hands, great. So OpenSearch has supported traditional observability for a while, for many years, and with the V3 releases, it has expanded into agentic observability. So the pains we talked about before, you can see examples of how we can address that. You can visualize and explore your AI traces aligned with the OTel semantic conventions. You can see and understand the agentic workflow steps and the logic executing in your production environment. And of course, I didn't show also the token cost and count and all of that. Agent Health is another great tool in the OpenSearch suite to help you develop AI agents more productively, more reliably using evals and observability. So you can define golden path trajectory and run comparison across your runs with LLM as judge and give you a score, a pass-fail, along with the accuracy, 0 to 100, and you can get also the reasoning and even improvement suggestions. So you can now experiment to compare agent V1 versus V2, or compare Claude versus GPT versus Bedrock, all with the same test suite, with the same judge. And by the way, you can also plug it into your CI/CD pipeline to automate the quality gating and catch regressions. And later today, I'll actually have a breakout session with Mega here to show more about this and show actually a live demo of this in action. So you're all welcome, of course, to join us 12:10 in the Barcelona room. And there are many other interesting open source projects that I haven't covered, of course, like LangFuse and Open Inference and Open LLMetry and many others that I urge you to use this conference and other means to explore. That Air Canada engineer had green dashboard. They had no idea. You now know why and what to do about that. AI systems are fundamentally different. The engineers who succeed will be the ones who aren't afraid to revisit their tools, their practices, and their base assumptions. So what can you do, even tomorrow, to get started beyond the big statements? First, start by instrumenting even one AI call or one agentic workflow with OpenTelemetry. Learn about OpenTelemetry, about OpenSearch online, and also join user groups. We have Cloud Native community group here in Munich, and also an OpenSearch user group here, and also in other cities around Germany and around Europe. Actually, this evening, there is an OpenSearch user group Munich taking place at 6. Of course, everyone is invited to join. And ask your team members, like, if AI said something wrong, can you observe it? Can you explain it? Start surfacing it in day-to-day conversations and surfacing awareness and these best practices with your colleagues. AI is taking over the world. The question is, are you ready to observe it? Now, I wrote a whole article about that in my personal Medium blog, so you're welcome to scan the QR code, and I talk a lot more about each and every one of these items, so do check it out. And actually, I encourage you to comment, challenge me, put your insights so that we can actually develop these evolving new practices together as a community. So this is the Medium blog, and don't forget to rate the talk for the organizers and to leave your feedback. I'm Dotan Horovits, and thank you very much for listening.